First, Mohamed, Sharaf with you. Today, our subject is to use signal builder or dynamic modeling with solar still. First of all, you have to go to your specify folder, destination folder, the folder that you download your model from here. Okay, and this is very important in order to present your photos and figures contained inside your folder. Okay, for solar still, our example today is solar still. I am going to demonstrate how to go through your many types of data extraction by the use of solar still as an example. Okay, first of all, I have three models here just for demonstration. This solar still with solar radiation model. Okay, I attached solar radiation model, so it's a different. Okay, it's a different model. So you have to calculate solar radiation model firstly, and before using solar radiation data, what per meter square for solar still. Okay, I'm not going for this one. I would like to demonstrate this one. This is familiar for everyone. Okay, solar still, this is a general model. Okay, double slope solar still. Okay, what we have here, we have you can run your model in if you specified your simulation time into 0, so you will get result as a single point results, a current point. So you can use your inputs such as what is your productivity per day. Suppose it's 5 kilogram per day. What is your average ambient temperature, daily solar radiation, megajoule per meter square per day. Suppose it's 15 as usual. This is daily average. Patient water temperature, suppose it's 50 degrees Celsius. Okay, and average wind speed. Area ratio, I think we can use 1.5 area ratio. Ratio between glass cover and basin area. Okay, operating hours, usually 8 hours for solar still is quite normal. 7 hours, 8 hours, something like this. For cost analysis, this is your interest rate, plant lifetime, glass cover costs, concrete or structure costs, land costs. Okay, per meter, US dollar per meter square. Hit apply. Okay, and now going inside and hit run, you will find out your results. Okay, this is our results. Efficiencies, solar still area needed. This is area for 5 kilogram per day, so 5 liters per day. Glass cover area. Okay, productivity kilogram per square meter per day, and cost analysis. Okay, now we have here what we have here. Before going dynamically or extracting our data, we have many types of data extraction. Let's beginning from the first. Going to here for model explorer. Okay, from here, click on it. Okay, choose the solar still design general model. Okay, and you will find all blocks here. We have two blocks, block for solar still and one block for cost analysis, and you have to choose any parameter you would like to explore and click on description and save final value to base workspace for exergy analysis, for heat transfer coefficient. Okay, thermal losses, gas temperature, any parameter you would like to discover, you have to save it as final value. Okay, as you can see here, interest rate. Okay, let's go for annual fixed charge, plant lifetime. This is for cost of the glass cover, land costs, and hit apply. Okay, this is the first method, so you can click here and hit apply. After running your model, you have to go outside here in your workspace, and you will find your results stored here, as you can see, because we have choose this by the use of Matlab or Model Explorer. So you will find your results. So you can use these results. You can double click on it, or even you can type it. Suppose I will type area of the glass cover, hit enter. I will see the area of the glass cover. Okay, any parameter stored here, you can use it. You can double click on it and you can explore it. You can export, even export. You can select one, shift. You can export all of these parameters into M files and so on. So these are Matlab capabilities. So if you're aware about it, you will use it very good. Now the second method is to going for dynamic model, but before going, you have to check your signal. This signal, you have to name each signal of this. You have double clicking and write. You can write the signal, as you can see here, the name of the signal. You can write it. You can edit it. Okay, but if you check, if you intended to check any signal, you have to click here for Matlab 2016. You have to check this small square box. This is stop streaming. This is stream signal, sending this signal name to the data inspector. So I'm going to use data inspector. Okay, or you have to check the signal and go in here and select stream selected signals to data inspector, or log selected to signal to workspace or so. So you can use this one. To be sure that everything is fine, you have to realize that there is a visualized signal box, small visualized signal box appeared here, so you can be sure that your signal is sent to the data inspector. Okay. Secondly, I have to using time limits. Therefore, I have to set my simulation time into infinity if I would like to run my model for infinite time limits. So after that, you have to go to your output here, double clicking, and prepare your input menus, and going inside again, and be sure that your input menu is here, because I need to remove I need to move these scrolls right or left by using left or right arrows. Okay, while the time is running and the model is running. Okay, after you set your simulation time into infinity, hit run. Okay, let's hit run. Okay, and using the input, let's increase our productivity and see the effect. As you can see here, effect of productivity on the area. As you can see, increasing the productivity up to 1000 square meter kilogram per day. As you can see here, increasing the area. Okay, because these are dependent parameters. Suppose I need to increase the basin water temperature, the effect surely will be on the glass cover temperature and thermal power. Suppose I need to increase solar radiation. As you can see, solar radiation will decrease your area because the system is running under most efficient or sufficient solar radiation. Therefore, it's up to your design. You can run, as you can see here. You can change your parameters if you would like to study. Okay, stop. Okay, and let's see in our results in data inspector. Data inspector will store your runs. This is the first run, this is the second run, this is the third run, so you can compare many runs. I will show you now. This is your parameters, okay? Ambient temperature, capital recovery factor, annual fixed charge, and as you can see here, there is some kind of effect of solar radiation, and this is effect of this is effect of productivity, and here you are, this is your effect of solar radiation. First of all, you can go here and reduce number of plots, okay, in order to show you more plots. This is just for an example, okay. And let's go here for productivity. We change this. We change this efficiency. This efficiency. Solar stir area. Okay. This is the effect of productivity, and this is your effect of the change of the solar radiation. Okay, and we have here thermal average radiation, convection, okay, heat transfer coefficient, whatever, total exchange destruction, gas cover area, okay, and brine depths. Okay, enough for these parameters. This is just an example, and you can use data cursor in order to show your you can move the cursor left or right in order to show to represent some results if you would like, okay. And you can send your these data to a figure. Select send it to figure, okay. If you click here, you will send your result to a figure, as you can see here. I'm sending. It will take a little bit time, okay. We have to wait for a while. It depends on your computer or laptop capabilities. Okay, now this is Matlab plotter or figures. So you have to go here for figure show plot tools or properties, clicking here. So we can control our figure. We can control this. Okay. You can change your background. You can add legend or remove legend. You can change the line type. This is stairs. Let's go for line. Okay. We can remove this one. You can use bars, for example. Click here. You can change the color. You can increase your line width. So you find your lines like this. You can select the area or bars. This is bars. Okay. It's up to you. Okay. Now I have to close this one. Okay. Okay, this is the first run dynamically, just to I'm going just to show you how to deal with. Suppose I need to go within a specific time limits, within a specific time limits. So I have to, suppose it's 8 hours, so I have to simulate my time with 8 hours, right here, 8 hours, and going here to the data inspect to model configuration parameters. This is model explorer and this is model configuration parameters, and I should going to the solver, fix this step. I can use variable step, going to additional option, and maximum step time. I have to increase step time up to 0.001, for example, in order to give myself a little bit time to make some changes. As you can see here, your time segments will appear here. Okay, but first of all I have to return back again and double clicking here and return inside in order to this is input menu. I need to change this, therefore but before doing this, let's do another things. Let's change our limits. Just right click on your mother block or input block and going to the mask and choose edit mask or control M, so you can change your limits. As you can see here, this is your documentation, initialization, okay, parameters and dialog. Let's emphasize here. Okay, solar still productivity. The limit is up to 25,000. I will reduce this up to just 500 or 100 kilogram per day. Just an demonstration. 1 kilogram per day, and you can choose ambient temperature variation, daily solar radiation. You can it changes the limits. Okay, okay. Let's begin from 5. Let's begin from 5 solar radiation, 5 megajoule. Okay, up to 20. Basin water temperature. You can change average wind speed. This is edit parameters, so you can, there is no limits. Area edit, okay. Interest rate, it's from 0 to 1, quite normal, and hit apply. Okay, I'm sorry, I have to enter a value for productivity. Okay, it's let's go for 1 kilogram per day and hit apply, and okay. Now our model is ready. Double clicking, going inside. That's your sequence that you should follow. Okay, now this is our model is ready for run again. I will set my brine temperature, return back to 50, hit apply, and this is 15 megajoule or 14 megajoule. Okay, now already our simulation time is ready. Let's hit run and see. Hit running. I'm sorry, the time limit is quite fast. I have to change it again. Let's change, increase the time limit. Increasing the time limit, 0.000. Okay. Okay, now I think it's a stop. I have to increase the time limits again. I have to give myself a little bit time for this. First of all, I use this. Okay. Okay, I have to go here. Okay. Give myself another time. Let's hit 0. Okay. Okay. Okay, increasing here and okay to show the effect. Okay, now I increase this time limits. I increase the time limits in order to give myself 0.0001. Okay. Okay. Now I have to hit run and moving cursors or sliders to left or right. Let's hit run and see. Okay, now I have a time here. Time is ready. Let's go for increasing solar radiation. Increasing solar radiation. Okay, you will find your result within 8 hours or 8 seconds. Matlab is considering it 8 seconds, but in your work you will consider these are 8 hours. Okay, so I'm increasing productivity. Okay, 1 kilogram by 1 kilogram, as you can see here. Increasing temperature. Okay. Okay, as we are at 5. Okay. Okay, 8 hours. increasing productivity and basin temperature. Okay, solar radiation increasing. Okay, okay, fine. Returning back to your data inspector. Okay, and you will find your results, previous results, are still stored here. This is your previous, so you can add your current results. This is annual fixed charge. Let's put annual fixed charge. Of course, you'll find a huge difference because this is in infinity time. You will not see it. I have to remove this one. I have to remove this one. Okay, I have to remove this one. Click here and click delete. Okay, and we can put current results. Okay, annual fixed charge. Okay, I'm sorry, I forget to remove all of this. We have to remove all of this and we have to run our model again. Okay, let's go inside again and let's make some changes and hit run. Hit running. Okay, within 8 hours, that's decreasing productivity, system productivity. You can fix solar radiation and removing, because this is a design model. We control productivity in order to discover the effect on design, your area, grass cover, okay, heat, thermal losses, and so on. That's decreasing within 8 hours, 3 hours. Okay, that's increasing again. And you can pause your model and make your change and return back again. This is another method. I will show you how to do it. Increasing solar basin temperature. Okay, increasing solar radiation again, and solar still productivity increasing again. Okay, and let's go for, okay, final time, final hour. Okay, that's it. Okay, and inspecting our making going for it. Okay, you will find your time limit is from 0 up to 8. So we have to, this is your current run. This is annual fixed charge, decreasing and decreasing because you make your changes, efficiency and thermal losses. Let's go for thermal losses and total exergy destruction rate, and grass cover area, and brine depth and centimeters. Okay, enough for this. I will keep this. Okay, I will keep this and return back again and hit running, going for 8 hours. Okay, and make another run. Okay, let's go for 8 hours and make another run, trying to that's increasing our productivity. Okay, and decreasing solar radiation, whatever you would like to change, decreasing. Actually, this method will not help you in order in the manner of seeking which parameter has the real effect on the system. So we have another method. We have to go through another method. It's just showing you dynamically how to control your system, or to feel the system, or to feel which parameter has the effect on the area, which parameter has the effect on thermal losses, which parameter has the effect on temperature. But you can still use it within individual results. Okay, you can fix solar radiation and temperature and change the productivity and see this is a change of the productivity effect. Okay, and you can I'm sorry, you can compare runs like what I'm doing now. I will compare runs now. I have 2 runs. Run number 1, this is run number 1, and I'm going for run number 2. This is annual fixed charge. Let's go for, this is the next run. First one against the next one. I'm just opening your mind for some ideas, for some plans about how to use data inspector. It's up to you, still up to you, in order to show or represent to yourself what is my best option. iTotal, let's go for iTotal here, and gross cover area, brine depths in centimeters. As you can see here, you have 2 runs, so you can compare your results. Okay. The third method is to use another different type. Let's delete all. Okay, and you can surely send your results to the figure, and as we demonstrated before. Okay, I have prepared another. You can save as your model. Save as with your save as, for example, 1, 2, 3, 4, for example. Hit save. I'm sorry, I have to save it with another name. Let's solar still trial. Okay, solar still trial and save. Okay, now let's go for another method for data extraction. And let's see what we can do about that. Hit your simulation time into 0. This is a different method, and you can go for model configuration parameters again, and going for variable step, make it fixed step. Hit apply and OK. Now we have to change the inputs. Let's control M. And going for control M or right click here and go for mask editing, dialog parameters, and going here. Now I have to change solar still productivity into an edit. Therefore I have to go here for slider and selecting edit. Okay, now you can enter your it's 1, for example, and going for ambient temperature, you can make it edit. Daily productivity, you can make it edit. Let's go for this. I will make solar radiation as edit. I'll write 15, and basin temperature I will convert it into edit, and 50 degrees Celsius. Average wind speed you can change. I just make some. I will need to change another parameter. That's enough. If double clicking here, you will find I replaced your results. I'm sorry, I replaced your data inspector inputs into edit instead of a slider. So I can use this for another method. Okay, let's go inside here. Okay, open your input menu. Okay, now suppose I need to inspect the change under a variable step. I can use solar productivity from 0.5 kilogram per second. I'm sorry, kilogram per day. Step 1 up to 10 kilograms. Okay, at basin temperature 50, Average solar radiation 15, 8 hours. Hit apply, okay, and run. I will see your results stored as a matrix. As you can see here, if you emphasize your results here, you will see it as a matrix. We step from 0.5 up to 10 kilograms. Okay, how can I use this? You can go inside here, go outside here, going for, you will find your value here as a matrix. Okay, for example, annual fixed charge, you will find it as a matrix. Any parameters which is depending on productivity as a matrix, you will discover your results as a matrix. So you can click on just let's go for example thermal radiation losses through the glass cover, and going to the plot and hit plot. Just hitting plot, you will see your results here. So I can go here inside parameters, and I can add from here, going from here, I can add more figures. Let's remove this one. Click on, this is your background. You can change it to the white background. You can click on, you can make it box or like something like this. Okay. Okay, for example, hit your target. Okay, hit your target and click on add data. Okay, and you can see your results here. Suppose you have to auto, you can go for solar, you can use productivity. What is yes, this is productivity, or you can use it from here, solar still productivity. Okay, I'm sorry, this is X, I can use okay, X is solar still productivity, yes, versus, and Y is thermal losses through the glass cover, and you will realize the figure. Okay, let's hit another with radiation. Okay, and we can use it versus for example exergy analysis. Let's go for exergy analysis. Okay, as you can see here, so you can use, suppose I have different parameters. If you enter this as a matrix, you have to different parameters. I mean, I need productivity. You can enter it as a matrix. I need productivity 1, 2, 3, 4, 5. This is 5 values. I need to change the solar radiation as well. So you have to enter the same dimension of your matrix. You have to enter 5 values. For example, 14, 15, 16, 17, and 18. 5 values. What is the effect on basin temperature? Okay, it's from 50, 52, 58, 60, and 65. Okay, and when the speed, you can change it as a matrix. 0.1, 0.2, 0.3, 0.4, 0.5. Okay, and area ratio, you can change area ratio if you would like. Let's go for this parameters and hit apply. You have to enter 5 values per each matrix in order to discover the effect. Hit saving, time 0, hit run, and you will, let's see our results. The same dimension for all parameters you are going to discover, and you will find your results, all your results are stored as a matrix. Okay, column, or let's go here outside, and you can draw some figures. Suppose I need to draw water temperature with Q. hold control key and you can write. Okay, as you can see here there's different, and suppose I need for solar radiation. Let's go for solar radiation and or productivity, the effect of productivity. Yes, productivity with total exchange destruction. As you can see here, 4 values, 5 values, is up to you, Q versus Q. Okay, you can draw multiple figures. Okay, control, and you can use multiple figures, so you can use different figures at different values. Let's go for solar cell area versus radiation. As you can see here, you can choose this one and change your limits, your parameters. You can select bars or area, whatever, as you can see here. Now this is another method, so you can handle it. You can clear and CLC. Okay, you can use it, and it's quite good for you. Now we have different. We have another method dynamically. Another method dynamically. As you can see here, your results are stored as a matrix, so you can discover this. As you can see here, five results, because your data are 5 inputs. Okay, let's go for another method. I will close this one, not saving. I will remove this one. Okay, let's hit back here. Okay, this is our original model dynamically. Let's go for sure, you can use you can send your outputs. Open your Matlab browser here. This is another method. Going to sync and choose to mat file or to workspace. It's up to you. You can use your results in mat file with time, so you can store your results in time, and you can use it and draw it if you would like. We can use another method. We can use my favorable method is to use going to sources, and we can use our data inspector for via signal builder. Signal builder is quite interesting model. Okay, you can use it, but before using signal builder, I got another idea. You can use dashboards. Let's go for dashboards. Dashboards, you can go here and dashboards, and you can select slider or switch or button or whatever. You can, let's go for slider, and you can, for example, use it. This is our productivity here. Okay, this is our productivity. Instead of opening your input menu and returning back again, you can use it here. Suppose I need to go for area ratio or productivity, so you can double clicking, and you have to link your block. Okay, you have to link your block from here. But first of all, you can, let's saving this. Let's save as solar still 1 2 3, for example, and save as. Let's go and making some changes. You have to put, for example, 1, hit apply, and double clicking here and select your block, so block you're attached, and you can control your limits from here. Your limits, what is your minimum? It's 0.5, for example, and my maximum is 10. Okay, you can select your how to name your model and hit OK. So you can control your data, your inputs, via this slider from here, from the current or the working model, and you can move it whatever you would like. Okay, this is your productivity, and we can select our result, such as gauge, for example, gauge, and we can connect something like solar state area, and we can clicking here. What is your minimum area? Is 1 square meter, maximum is 10, for example, or 100. Okay, and we can add. It's from 0 up to 10. Give me color blue, and from 10 up to 50 give me a red color. Hit apply and OK, and you can run your model. But first you go outside, Control M, okay, and going here, going for solar state productivity, and going to enable or visible, and check this, remove this, okay, and hit apply in order to control the system from inside. Now we can control from here, and you can do the same for any parameter you would like. Let's hit run, and let's adjust our slider beginning from 0.5. Let's hit run and see. Okay. Okay, let's increase. As you can see here, the area is changing. Area is changing. 0.7. Okay. Okay, 1. Let's go. As you can see here, you realize slightly change here, increasing the productivity up to 2. Okay. Up to 10 kilogram. 3. I'm sorry. Okay, that's it. Stop. We can change this, increasing the limit if you like up to 100, and you can choose a step. What is your interval? You can use 10, for example, or 20 step, as you can see here. And let's hit run again and see. It's increasing the productivity, and you realize the effect on your parameters. Solar state area is increasing, as you can see. Okay, let's hit stop and moving this one. Opening our, let's move this, returning back to our model. Ignore this one. Okay. Okay, this is our normal model, and let's go for another model, another type. I'm sorry, another type. Let's go for source and choosing signal builder. Signal builder is it's a very useful method in order to assign your inputs within a realistic change of your weather operating conditions. What we have here, signals. You can choose number of signals. Okay, double click on it for size as an input to your system. And this signal should be changing with your time limits. Okay, let's go for I need let's first of all you have to change the time series. It's from 0 up to 8 hours. Okay, okay, so we are from 0 to 8 hours. Suppose this is or you can change from let's go from 8 o'clock. Let's go from 8 o'clock. I have to go here and select parameters. I will begin from start time from 8, and my end time is 16. That's my 8 hours. I hit apply. Okay, so this is 16 hours. and I have to reconfigure my signal builder with the same. Going to access, change time range, minimum time is 8 morning to 4 o'clock p.m. Okay, you will change your time from 8 up to 4 o'clock p.m. Okay, now we need to suppose this is solar radiation. Solar radiation at 8 o'clock. You can at 8 o'clock it's around 10 megajoule. Okay, so this is at 8 o'clock. Okay, at 9 o'clock you have to hold shift and click here, and you can, let's go and make many inputs. I'm sorry, holding shift and click on your signal. Okay, this is a variation of your this is quite important for designers. Please concentrate with me. Let's go in here. This is 9 o'clock. Suppose it's around 11 megajoule. Okay, and 10 o'clock it's 12 megajoule, and 11 o'clock it's 13, and here we have 15, and at 1 p.m. the 13 is 1 p.m. at 13 it will be 14, reducing again at 14. You can use it as 13, and here at 3 o'clock p.m. it's 12 again, and at 4 o'clock evening we can 4 o'clock p.m. we can use it as 10 megajoule. Okay, this is a variation of our solar radiation. Okay, this is variation. Saving. We can add another signal, new signal. Let's begin from constant, and we can name this signal. You can name this. Click here, and signal name you can name it as solar radiation. Okay, megajoule per square meter per day. Okay, this is your signal. Okay, and this signal is for example basin temperature. I will name it as T basin temperature. Okay, and suppose I have a different value of basin temperature. Suppose it at 8 o'clock it's let's say doing some increasing, adding some points. Click here, shift. Okay, adding some points. You can use at every step, or you can increase your step time. Okay, and okay, let's go here, and suppose I will begin my at 8 o'clock it's around 35 degrees Celsius, and then we have a slightly increasing, okay, within basin temperature with respect to solar radiation, as you can see here. So we are going up to 60 degrees Celsius. Okay, and still constant, and then it returns back again with slightly decrease. So you can as you can see here, down to this final value is down to 38 degrees Celsius, for example 38. Okay, and we can add another signal. Let's go add another signal for productivity. Okay, I will name this productivity. Okay, this is kilogram per day. Okay, productivity, let's go for at 8 o'clock morning, suppose it's 0.1. Okay, and then at 9 o'clock it increased slightly, and let's increasing, and 12 o'clock, I'm sorry, that's increasing for let it be at from here, increased at 1 kilogram at 12 o'clock and remaining constant, and decreasing whatever you like. You can, I'll just demonstrating. Okay, you can control your signal input. Okay, and close this one. You will find 3. You can add many signals if you would like. Let's go here for productivity. Okay, suppose I will save this file as zip solar still AAA, for example, saving. Okay, and let's remove this one, but first of all you have to go here, Control M, parameters. We will change, so we have to eliminate productivity, we have to eliminate solar radiation, and we have to eliminate present temperature. Hit apply and okay. So there is no need for this one, so I have to remove it, put it here, and solar radiation, Control X, Control X, and Control V, and present temperature, Control X, and going here. I will not, and let's go for here and choosing sync terminator in order to close this stream, not full alert of unconnected stream, and turning back again. And this is solar radiation, so I have to connect solar radiation. I'm sorry. Base in temperature, I have to connect base in temperature. You can reorder this if you would like. And productivity. Now saving your and hit run and see our results. So our signals will change your results. As you can see here, data are changing with time based on your signal you have input. You can add the variation of wind speed, the variation of ambient temperature signal, the variation of solar radiation, the variation of at constant productivity, and then you can change your signal to add another range of productivity. And you can, I'm just opening your mind with different ideas about how to use data inspector with respect to a signal builder inputs of your operating conditions. You can add your operating conditions at different types, at different moments, at different time domain, and you can discover the effect of that. Let's go here for data inspector and see our results. Okay, as usual, going here. Okay, this is the change based on your solar radiation, or this is your solar radiation, solar still area. Okay, thermal losses, heat transfer coefficient, the variation, different results you will get. It's about your signal builder. Build it right, you will get right results, and very attractive results. Finally, I would like to thank you very much. I hope that I demonstrated your targets. I hope that you become satisfied with this video. It's about data extraction from by the use of signal builder or different type of data extraction to your results. We demonstrated solar still as an example for your results. Don't forget to like, share and subscribe. Thank you very much.